Hi everyone! In this video, I'm going to solve one of the most popular Amazon interview questions on LeetCode. So this is kind of very tricky, LeetCode hard dynamic programming question that frequently asked by Amazon these days. In order to solve this, I draw graphs and explain general ways to solve dynamic programming and all the good stuff. So if you are preparing for interviews, or if you have Amazon interviews, and if you're just generally solving LeetCode problems, subscribe my channel and like this video, then you're gonna be lucky during the interview. Alright, let's solve the problem. This is 1335, minimum difficulty of a job schedule. So this problem was kind of tricky because at first time when I was trying to solve it, I couldn't understand what this really means. So I'm going to read the prompt and I'm going to kind of rephrase the problem so that normal people like me can understand the problem. In this problem, you're going to have two inputs. One is job difficulty. It's an array of integers. And then you're going to have an integer d. D means the day. So the problem is you want to schedule a list of jobs in d days. And there are some restrictions. Jobs are dependent. It means that in order to do this job, you need to finish this job first. So it means this restriction means that sorting is not an option to solve this problem. And also there are other restrictions. You have to finish at least one task every day. And then this is the real problem here. The difficulty of a job schedule is the sum of difficulties of each day of the d days. The difficulty of a day is maximum difficulty of a job done in that day. And then what you have to find is return the minimum difficulty of a job schedule. So what does this mean? It was really hard to understand what it really means. So I'm going to rephrase the problem here. Okay, let's try to rephrase the problem.
So split job difficulty array into the number of subarrays and find min of sum of the largest integer in each subarray.
So what it means is that if you have this job difficulties array, and then let's say that d is 3, that day is 3, you slice this array into 3 subarrays, and you have to pick the most difficult job, right? It's going to be around here, around somewhere here, and then so this is going to be the largest number, the largest integer in this subarray, the largest integer in this subarray, the largest integer in this subarray. The sum of these, so large 1, large 2, large 3, sum of number have to be the minimum, right? So that so it means that we have to slice this array well, so that the maximum of these difficulties are minimum as possible in this job difficulties array. All right, let's try to solve the problem. Let's say you have input of 6, 5, 4, 3, 2, and d is 3. All right, so you have 1 day, 2, second day, third day. What work can you do on the first day? You can do 6, 6, 5, 6, 5, 4, 6, 5, 4, 3, 6, 5, 4, 3, 2. All right, on the second day, you might be able to do 5, 5, 4, 5, 4, 3, 5, 4, 3, 2. Or you can start from 4. Let's say on the first day you did 6, 5, and then you could do you could start with 4. So that's why here's 4, 4, 3, 4, 3, 2. Or you might be able to start from 3, 3, 2. You might be able to do 2. On the third day, let's say on first day you did 6, second day you did 5, you might be able to start from 4, 4, 3, 4, 3, 2, and 3, 3, 2, and 2, right? If you start from 6, you can do all of this work on the second day. If you did 6, 5, you could do all of this work on the second day. The problem states that on each day, we pick the maximum difficulty, and then the maximum difficulty of 6, and then let's say you did 5 on the second day. That's maximum 5, so the total difficulty is going to be 11. And then you did 6, 5, and then you need to choose 4, 3, 2. The maximum difficulty is 4, so it adds up to 15. And then let's say you did 6, 5, maximum is 6, and then maybe let's say you did 4, 3 on the second day. So max value of the second work is 4, so it's gonna be add up to 10, and then you did 6, 5, 4, 3. All you have to do is 2, so the total is 12. And then let's say you did 6, 4, 5, 6, 5, 4. You have 6, and then you could do only 3. Then that's gonna be 9 and 2, and that's gonna be 11. So as you can see, this is how you try every single combination of work this way. And as you can see, this is graph, and this is directed graph. And so we can tell that this is DAG, DAG. DAG doesn't have a cycle. DAG is directed acyclic graph. So if you have DAG, it means that actually you can use dynamic programming recursions to solve this problem. All right, let's think about dynamic programming. If you watch MIT courseware, there's a famous algorithm course there, and I'm gonna leave the links below to link to the YouTube channel. And from that lectures, Professor Eric introduces that if you know like 5 things, that you can solve any dynamic programming problem. I'm going to introduce a couple things. First is state, or you can call it a subproblem. All right. And then second, guess. So dynamic programming is about to solving a subproblem, and in order to solve that subproblem, we have to guess. So it means we have like min or max to find the problem or whatever, and then we have recurrence relation. If we have these 3, we can solve any dynamic programming problem. So let's do number 1. Let's state our DP. So let's say we have this DP and D and I. All right. So let's state this DP. So from this, our answer, we can actually think about our answer. Answer is going to be DP of D and 0. So what it means is that find out the answer from this whole job difficulty array, and then we have this D day, so we have to split this array into D number of subarrays, and then from this D number of subarrays we get the mean of sum of max value, right? So that's gonna be our answer. So now, what do we have to guess? Let's think about guess. So the guess that we have to make, is find maximum value from the subarray. All right, and then let's think about the most important thing. So recurrence is very important. Let's think about the recurrence. What we are trying to find is min of max of, let's say D. D is job difficulty array input. So from arbitrary J to m minus D plus 1 plus dp of day minus 1 j plus 1. And then let's define this j range. For j in range of I n minus d plus 1. I is for I in range 0, n minus d plus 1. All right? So if we find out this value, we can find answer. Yeah, so what this means is that if you have these job difficulties, and let's say you're cutting somewhere here. So in order to find dp of di here, right? What was the minimum answer from here? That's what this is doing. So it might not completely clear yet. So let's try to draw another graph to help us understand this dynamic programming algorithm. Okay, let's draw another graph here. Let's say you have input of 7, 1, 7, 1, 7, 1, and d is 3. This is an example from LeetCode. So you're going to call dp of 3 and 0. And dp of 3 might call max something like 7 and plus dp of 2, 1. And then this one is going to call max. All right, and then this might call max of 7 plus dp. All right, and then this might call max 1, 7 plus dp 1, 3. Okay, so and this is gonna call something, and then this one might call 2, 2, and this one might call max of 1, 3, and so on. So as you can see, the dp call dp13, dp13, we are computing twice, right? As the tree gets bigger, d is larger, we're going to have a bunch of this same computation over and over again. So in this case, in dynamic programming, we can use memoization or dp table. This is for bottom-up approach. This is for top-down approach. Yeah, I was just drawing this graph to visualize the call. Now, let's think about the complexity. What is the time complexity of the algorithm that we saw? So time complexity is going to take big O of n squared and d. D as day. Okay. In dynamic programming, normally, the time complexity is number of subproblem multiplied by time subproblem. Number of subproblem multiplied by the time it takes to solve the subproblems. In our case, the number of subproblem is actually big O of n d. And then in order to solve the subproblem, it takes n because what was our guessing? Our guessing part was to actually find out the maximum value in the array. So in order to do that, in order to find out maximum value from some sort of array, we have to iterate all of these elements. So that's why it takes n. And then subproblem, the states, number of states of our dp is nd. So that's why our time complexity is going to be big O of n squared d. And then what about space complexity? So the space complexity is going to be the number of subproblem and number of states, right? So because we are storing those function call and then the return value of it, so that's why it caused nd for space complexity. All right, so with that, let's code this problem. All right, let's solve the problem. So before I write code, I'm going to copy and paste my note here. This is something that I talked about before. So let's think about the base case. So this is base case. Job difficulty, the length of job difficulty copy and paste, is if it is less than D, larger than D, no, it's lesser than D, return -1. What it means is that there are more number of jobs, there are less number of jobs than the day. We can't possibly split those jobs into the number of subarrays. That's why we return -1. And let's define our DP. Def DP is, our DP is, DP takes day integer and cut integer, and it's gonna return integer. When you're writing this recursive function, the most important part is actually base case. So base case is when day is 1, just return max of job difficulty from the cut. All right. When day is 1, we don't really need to split anything. We can just return the maximum value from that cut. All right. Now what we gotta do is having this recurrence relationship correctly. So let's say we need j range cut. We need this value minus d plus 1. So we're using this twice, so let's try this out. Let's say num jobs. Let's use num jobs here, num jobs here. All right, looks good. What we gotta do is max so far. Far is max so far. Job difficulty of j. So this one is trying to represent this. All right. So we need to define max so far before 0, and then we're gonna have this. This is the answer. So we're gonna define our answer here. This one we can float infinite. So our answer is min of max so far plus this function call dp day minus 1 j plus 1. I think, oh yeah, and also this should be day. After we find an answer, what do we have to do is just return answer. And also we define this dp now. What we gotta do is just return this answer. Return and dp. All right, let's try to run this function. Of course, int object is not iterable. 925 int object. Oh, so answer should be just answer and max so far plus dp. All right, let's run this code. Okay, it passes. All right, so I submitted the program, but this is not gonna pass because it's gonna get the time limit exceeded, because this is kind of without memoization, so it takes a really long time. All right, time limit exceeded. So let's add memoization. Adding memoization is really simple. Memo here, and in the recursive function, if they cut in memo, then return memo they cut. Yeah, so in this kind of case, I really like having tuple of day and cut as a key, and then value as the previous answer. So we got this base case correct, and then if we just add memo they cut after finding answer, then it's gonna work. Let's submit. All right, it worked. So it's faster than 31% of Python 3 submissions. The reason why it's slow is because a lot of folks load the library called import func tools, and this has nice decorator function called LRU cache. So we can actually use LRU cache in this case. Let's try to be fancy here. With that, we can actually abandon all of this memo. But I feel like it's kind of like cheating during the interview. So that's why I kind of build up the memo hash map. Yeah, so let's run this program. Oh, so LRU cache size none. Yeah. Okay, success. Faster than 80%. Yeah, that sounds good to me. That's good. So we solved with top-down approach. Now let's solve with bottom-up approach. I'm gonna copy and paste here, change the function name, top-down, and bottom-up here. So bottom-up is actually very similar. So once you get this recurrence relation right and all the logic is correct, then actually writing bottom-up is very, very simple. So base case is gonna be the same. And after base case, what you gotta do is build up the table. So a lot of people build their, most people just name their table as DP. So I'll just follow that. Previously, we had our dummy answer as infinite. We're gonna do that here too. Float inf, and then we're gonna multiply by num jobs. Here's something interesting. We're gonna add this 0, all right? And then for I in range d plus 1. Adding some sort of dummy values on the first row. This is necessary because when you're building up the table, you always need previous calculations. But when you're doing the first calculations, you don't really have the previous calculations. So this is just a convenient way to get all the ranges correctly. All right, so this is just a really common trick. After you have DP, let's fill up those tables. Okay, so we are gonna have for loop for day in range 1 d plus 1, because they start from 1, not 0. This is like a, d is real number, human stuff, not 0th index, so that's why we are starting from 1 and adding 1 here. And then after that, you're gonna have cut, and then cut range is going to be the same, same as before. So num jobs, and then after we have this cut, from top down we always had this cut, right? We're gonna have j in range. You start from the cut, where the cut starts, and then it ends here, ends before this value. Right, this value is getting used twice, so I'm gonna try this out right here. So this is just gonna be right. This is gonna be right. All right, and then J, the recurrence relationship here. This is not gonna be exactly the same, but almost similar. Oh yeah, so this guy here. Oops. All right, copy and paste, success. Answer max so far, DP. All right, so bottom up approach, instead of this function call, this is 2D array, so we have to make it as array. All right, and then after we find an answer with DP table, what we gotta do is fill up that cell, DP day cut is answer. With that, we can just return DP day cut. All right, let's try to run this program. Top down, bottom up, we have to probably remove this to run this function. Let's run this. Okay, wrong answer. Why did I get it wrong? Cut right. Max so far. Job difficulty. Answer max so far. They cut. It should be right. It should be D and 0. Yeah, I was stupid. Yeah, I don't know why I made that mistake. The return is actually the same. Yeah, so as you can see, once you got the DP statement, answer, and recurrence relation, and if you can come up with like a high-level top-down approach, you can also use that top-down approach for solving bottom-up approach. So yeah, this is it. So alright, so this is the end of the video. If you think this video was helpful, please subscribe my channel and like this video. Your support is going to be very helpful for this channel's growth. So if you're currently preparing for interviews or just practicing algorithms and LeetCode, really subscribe my channel. I'm going to upload more videos about this and a couple fun videos of tech world. Yeah, so stay tuned, be safe, and have a good day. See you later.